Hello everyone, welcome back to another BGCSE past paper review. Today we're going to review the combined science paper, and this is a paper 2 from the year 2015. Again, always remember, write your school number, write your candidate number, write your surname and your initials. Again, read through all the instructions before you start the examination, and also follow the directives of your examiner. For the combined science paper, they will provide you with a periodic table, which is great. You can use it if you need it. And let's jump into the first question. The first question reads that the particles of matter are in constant random motion. It says some red candies were placed in a glass of warm water. It says suggest what would be observed after 1 hour. So after 1 hour, this is what happened. The water would change to red, or the red color or the red pigment will diffuse throughout the water. Okay, so the water will change to red. Okay, and it's simply because the pigment of the candies will diffuse throughout the water. Just to make a note of that. Is to explain this observation. So this will put that part now. It is simply because the red pigment will diffuse throughout the water. Okay, the red pigment of the candies will, let's say, diffuse throughout the water. Okay, all right. So that's the answer there. And now for part 3, is a state what happens if cold water is used. Now if cold water is used, then the kinetic energy will be less, and so therefore the rate of diffusion will be way less, and so therefore the pigment would not be throughout the entire water. Okay, so the pigment will not be seen throughout the entire water. So more like what will happen here, the bottom will be red and the top will be clear. Okay, so let's make a note right there. So just to put this right here, the top, let me just say top equal to colorless. So the top part of water will tend to be colorless because no color will be there. Okay, and the bottom part, the bottom will be red. All right, just to give it this piece right here. All right, so that pretty much would happen in terms of the cold water versus hot water. Okay, because again, the lower temperature, lower kinetic energy, particles move less, the rate of diffusion is also less, right? However, part B is the table shows some gases and their relative molecular mass. And so we have ammonia, we have carbon dioxide, we have nitrogen, we have oxygen, and we have their masses here. And this part is saying arrange the gases in order of rate of diffusion from fastest to slowest. And so we're going to use the relative molecular mass to determine how fast they will diffuse. And so we expect the heavier the gases, the slower it will diffuse. All right. And so here, so we're going to put them in order. So we can put first here, which is 17, which is ammonia, should be the fastest one. So let's put ammonia right here. Okay. Ammonia is the first one. All right. The second will be, matter of fact, just for space, let me write out the formula. Okay, so ammonia will be the first one here. You can write the names in exam. It never asks you for the names, but you can write out the name. All right, I just want to make sure I could hold the space right here. So this is ammonia. It's 17, so it'll be placed right here. If it asks you to put the mass number, you could use the mass number as well. So again, look out for what they ask in the examination. Here didn't specify whether the name, whether the mass, or the formula. Okay, so the next one here now would be on the list, which is 28 out of 17. Yep. So this is nitrogen. So this is the N2. Okay. All right, and then the third in the order right here is be oxygen, which is 32. So oxygen will be the next one here. All right, we're going in increase in number. And after oxygen will be carbon dioxide, which is the heaviest one, which is 44 grams. So this will be CO2 right here. All right, great. All right, so that will be our order, starting from ammonia, which is the lightest one. The heaviest one is carbon dioxide. That will be the last one. All right, great. All right, let's jump to the next part of the question now. We said, explain the order of the fusion of the gases given in part B1. And so here now we can talk about the masses. And so the heavier the mass, the slower the rate of diffusion, right? Or you can say the greater the mass, all right, the slower the rate of diffusion. All right. All right, great. All right, so that will be our answer there. All right, and you could do it another way by saying the smaller the mass, the faster the rate of diffusion, right? So either way work. Let's go to the next part of the question here. It said the chart shows the basic changes in the state of matter. So we have solid, liquid, and gas. And then we have sublimation, and then we have some numbers going across there. And so here now it said use the kinetic theory to explain the changes, the changing state shown by arrows 1 and 4. So let's go to arrows 1 and 4. So arrow 1 is moving from liquid to solid. And so therefore moving from liquid to solid, what is happening here is that the liquid loses heat because the moving to solid get cooler, so it loses heat. So the liquid loses heat, right? And so once it loses heat, now the particles, so let's say right here, the particles move slower. All right, move slower. And this is because of less kinetic energy, just put it in bracket. This is because of less kinetic energy. Okay. All right, and so as a result of this now, it's caused the particles to move closer, all right? So hence the particles, all right, come closer, or particles are closer to each other, okay? All right, so then the particles are closer together, and so that's how the solid is formed. For arrow 4, let's talk about arrow 4 right now. And then arrow 4 is from liquid to gas. And so right here now, the liquid now will gain some heat. So the liquid here gain heat. Okay, so the liquid gain heat. And that's heat energy, a matter of fact. All right, and so the particles now, the particles move faster. Okay, so the particles move faster. All right, which is because of more kinetic energy, just put in bracket as well. There's more kinetic energy. Okay, more kinetic energy. And because of more kinetic energy, the particles will spread out, okay? So the particles will spread out. All right, so great. All right, this is, okay, I put a Q. Great. All right, so that will be the answer there. And so that's the end of the first question. Let's jump to the next question right here. And for question number 2 now, so the diagram shows a section through a nephron. And here we have a branch of a renal artery of the renal vein. And so let's quickly run through this. Matter of fact, let's label A. And A here is the Bozeman capsule. That's the Bozeman this is Bozeman capsule. All right, and B will be our first convolution, which is known as the proximal convolution. It's a proximal convolution. All right, and the proximal because it's closer to the Bowsman capsule, right? The last one over here be the distal, all right, convolution, just to make a note of that. All right, and then we have our collecting duct, which is right here, and then we have a loop of inlet at the bottom right there, right? Now let's see what they're asking us right here. It said name the process occurring at structure A, and so structure A, which is the Bowsman capsule, and so the process as is taken there is filtration. But to be specific, it is ultrafiltration. This here is ultrafiltration. All right, and so for part 2 of this question, it says state 2 differences in the content of blood entering and leaving the kidneys. And so I could give you more than one. Well, there are 3 major differences that you need to think about. All right, but again, you can also add some more than even 3. But what I like to do in exam is to kind of do something like this and just put a line down, and it's just a habit to do that. Make it kind of easier though. And so I could put on this side what is entering, and I could put on this side what is leaving. And so what is entering the kidney right here, for one, we could have more, so first point, we could have more urea. And what is leaving, we have less urea. So the first thing to think about the kidney is urea. So once you come on the kidney is urea, because remember the kidney will take out urea out of the blood. So you have less urea leaving the kidneys. And then another one here could be more water going towards the kidney, because remember the kidney will form urine. There's more water. What is coming out of the kidneys will be less water. Okay, be less water. And also we could have more salts going in, because these are the 3 major components in urine. So I'm just putting in there. So that would be more salts going. What coming out will be less salts. Okay. All right. So great. So there we have it. 3 differences. They asked us for 2. All right. You can even put more than 2. You can talk about glucose and so on. If needs be, but these are the major 3 that you need to think about first once you talk about the kidney and content entering and leaving. All right, so let's go down to part 3 of this question. It said name one substance which is reabsorbed in part B and state its use in the body. And so what is being reabsorbed in part B, which is the first convolution or the proximal convolution. A matter of fact, it is reabsorbed along the tubule. Okay, so anywhere in the tubule at the label could have been the same answer. And so the substance here that is being reabsorbed is glucose. Glucose. Okay. All right, so great. But what is the function of glucose in our body? Glucose is used for energy. Okay, so it is used. Okay, it is used to produce energy by respiration. All right, excellent. Now for part B, so the table shows the comparison between the daily intake and output of water in an adult. And so here we have the daily intake, which will be from drinks, food, respiration. The numbers 1,500, 700, 200 respectively. And the daily output will be urine, feces, sweat, exhaled air. And the numbers 1,400, 150, 200, and 400 respectively. So use the data in the table to calculate. So let's do some calculation right now. To calculate the average daily intake of water, show you're working. And so for here, the intake will only be 1,500, 700, and 200. So we're going to add up these numbers. So let's add these numbers. Okay, so let's add these numbers. So we're going to say 1,500 plus 700 plus 200, and that will give us here 2,400. That will be your total. And so the average here will be 2,400 divided by 3, because it's 3 of them. And so here we get 800 All right, and that is per centimeter cube. So let's go just put per centimeters cube right there. Let me draw in my cube. Okay, so that is centimeters cube. All right, so that will be our answer there for the average, and that is intake. Now it asks us to calculate now the difference in total intake and output water. So we already have our total here, which is a total intake. So let's look at our total output. And so if we add, let's go here. If we had our 1,400 plus 150 plus 200 plus 400, here we'll get 2,115, 2,150. Okay, yes, so 2,150. All right, and so we're going to take the difference between 2,400 and 2,150. And so let's write that out right here. So the difference here will be 2,400 minus 2,150. And so therefore this will equal to 250. Again, it is per centimeters cube. Okay, let me just put in my cube right there. All right. All right, great. Now let's now jump to the next part of the question. It said, name the hormone which regulates the amount of water in the body. And this is a name it, but I'm gonna give you the abbreviation first, and I put the name beside of that. So this hormone is ADH, and the name of it is antidiuretic hormones. It is antidiuretic hormone. Okay. Okay, so antidiuretic hormone. All right, so now go to the next part of the question right here. It's a name the excretory product found in human feces. For this question, I really don't teach feces to be an excretory waste because it's undigested food mainly. And so there are two main things that you find in feces. You find water, which is a great percentage of water, and the remaining portion will be organic waste or solid waste. So I'm gonna give you three options here, and then we could have a discussion about this. A matter of fact, you could comment in the discussion in the comment section possible answers for this. But I'm gonna give you three possible things that may work for this, because we consider feces to be undigested food, and remember that excretory product will really be from metabolic reaction, okay, or metabolic waste. So here, right here, I'm gonna put solid food, and the solid food I'm gonna talk about a matter of fact. So solid waste, let's say solid waste right here, and solid waste is really which is a form of byproduct of digestion. So being a byproduct, you can be considered as a chemical waste because the remaining portion that comes from digestion, right? So it's a byproduct of digestion, okay? And digestion could be a chemical process as well as also mechanical, right? All right, so another option here which I could put right here is that there's a substance that is formed, and that here is called sterobilin, okay? So it is sterocobilin, matter of fact, sterocobilin, and this substance here, it is really the remain that you get from red blood cells. So this is coming from when red blood cell break down. So this is from red blood cells, and bile. And so for our sterocobilin, cobilin is what give the feces its brownish color. So it makes feces brown. Okay, so it makes feces brown, just to make a note of that. Okay, so it makes feces brown. Okay, all right. It makes feces brown. And there's a next substance you may find in feces as well that you can consider as waste is hydrogen sulfide. Let me put it right here. I could put this also in red. Let's put it right here in red. And remember, this is for part C as well. This is another option you can think about is hydrogen sulfide. I'm thinking about right here. And so hydrogen sulfide is a gas, and hydrogen sulfide is produced by bacterial fermentation. So it's from bacterial fermentation. All right. And so it's a chemical process. And it is what gives that pungent smell of the feces. So when the feces smell really, really bad, it had a high content of hydrogen sulfide. So from bacterial fermentation, so because of bacteria fermenting the organic matter in the feces, you get hydrogen sulfide. All right. And this is the characteristic smell of rotten egg. So when eggs become rotten, you have that smell. You may find the smell also in the mangrove swamp that is produced by bacteria as well. All right. But again, these are the products that I'm thinking about that is in feces. Again, I never thought about or even teach that feces is excretory product. Okay. It's undigested food. All right. But those are the answers that I come up with. All right. So we can have a discussion about them in the comment section. You could comment about them and we could talk about it somewhere. Right. All right. So question number 3 right here. So the diagram shows an electrical circuit. And there are some components in electrical circuit here. And it said name and give the function of each electrical symbol. So I guess the symbols will be here. Let's just run through them real quick. All right. And so the first one on the list right here, it is a switch. So this one is a switch. And matter of fact, this is an open switch. But they just want to talk about what the component is. So you don't have to worry about whether open or close at this time. But this is an open switch. All right. And the function of a switch is to open and close a circuit. All right. So to open and close the circuit. Okay. All right. So that's the purpose or function of the switch. Now this is a battery, and please notice the different. You need to know the difference between battery and cell. Okay. A cell will be a single thing. So let's draw a cell on this side for you really quick. All right, so a cell will look something like this. Only one of them. The one must be longer, one must be shorter. The longer one is the positive side, the shorter one is the negative side. So that's a cell on the left, right there of the table. Okay, the battery is more than one connected in series. All right, and so here now we're gonna have the function of battery is really to supply electric charge to the circuit. Okay, so this is to provide electric charge to the circuit. Okay. All right, to provide electric charge to the circuit. And then here we have what they call a meter. Okay, this is the ammeter. And a meter is what you use to measure current. All right, so the function of this is used to measure, I could say to measure current. To measure current. And this is measure current in the circuit itself. And a point to note is that a meter is connected in series to the circuit. So if you're connecting a meter in the circuit, it must connect in series. Let's see if it's in the diagram. Okay, excellent. So the ammeter is in series. So notice the ammeter is connected in series. The voltmeter is connected in parallel. Okay, so that's something you need to know as well. That ammeter is connected in series, voltmeter is connected in parallel within the circuit. All right, so this here is a lamp or a bulb. So lamp, okay, or a bulb, okay. All right, and the function for this is really to convert electrical energy into light and heat, or generally light energy. So it's convert electrical energy to light energy, okay? Light energy. And of course you get some heat as well, but the main function of it is to convert the electrical energy into light energy. And this here is a fuse. Do not mix it up with a resistor, because the line goes through it. It is a fuse. Without the line, then it is a resistor, okay? And so the purpose of a fuse is to protect the circuit from excess current. So if too much current is flowing in the circuit, the fuse will break and prevent damage to the components. And this here now is a voltmeter. And again, remember that voltmeter is connected in what? Parallel to the circuit. All right, just to make a note of that. And this one is to measure voltage. Okay. or also potential difference. So you can also measure voltage or potential difference. To measure voltage or potential difference, okay, voltage, let me just put potential difference, PD in the bracket, okay, so you could measure PD, potential difference, all right, across components, and I'll put the word across, okay, so that's going to be important, across components. All right, so that's that right there, and so that will be our naming of the symbols and what they use for in the circuit. All right, so for part 2 right here, it says state what the arrows in the circuit indicate, and so arrows are going in the circuit. So if you notice here how the arrows are going, all right, and so the arrows will indicate the flow of charges, okay. So the flow, it indicates the flow of electrical charges, because remember in the circuit is the flow of electrons, right? So it represents the flow of electrical charges, all right. Okay, and remember that electrons will flow through the circuit. So electrical charges are the flow of electrons, right? So you can even say charges or the flow of electrons, okay, because remember it's electrons that are moving. All right, so great. All right, so now we have that covered. So we jump to the next part of this question here. All right, and this part of the diagrams show 2 different electrical circuits. And here it said name the type of electrical circuit shown by X and Y. Okay, and so X, just look at what X is. Remember that X now is flowing, there's one direction, one path for current to flow. And in diagram Y, there are more than one path for current to flow. So that will be a parallel circuit. So this one here is series. Okay, and the one here will be parallel. Okay, so here will be, okay, parallel. All right. All right, let me go back to my blue color. All right, and so part C now is to name the type of electrical circuit used in household wiring and give a reason for your choice. And this is definitely parallel circuit. So this is parallel circuit. All right. All right, and so the reason why you want to use parallel circuit inside of households or even industrial, really any buildings, really you want to use parallel circuit, and simply because because if one component, so if one component is damaged, it does not affect the others. Okay, so if it's damage or remove, you can say damage or remove. Let's put remove here. Damage or remove. So if you take out the light bulb, for example, okay, so if it's damaged or removed, okay, it does not affect the others. All right, so it does not affect the other components, because it would be sad though if your bedroom bulb is blown and then there's no light in the kitchen, no light in the hallway, everything stopped working. That would be a sad case, isn't it? All right, so yes, so it does not affect the other components at all. Now let's jump to the next question right here, and this one now is saying the diagram shows the male reproductive system. All right, and again, they only have a few labelings, but you need to know more than just what is there. So here is a prostate gland. Just quickly, let me just do that. This is a prostate. Okay, so this is a prostate gland. All right, and B is the urethra. Okay, and C here is the head, or what they call it, gland. So this is a gland. Okay. All right, let's say glands / head of the penis. All right, based on what labeling is. And D is the testis, is only one. Testes will be for 2 of them. Okay, so testis is singular. And E here, this is the scrotum or scrotal sac. Okay, this is the scrotum or the scrotal sac. Now for part A, it said use the letters from a diagram to match each function with its structure. And so one here, function one, it said allow both urine and sperm to exit the body. And this is the urethra. So that is B. Okay, that is B. All right. So this is B. It said manufactures sperm cells, and this is the testes. The testes do that. So the testis will be the correct answer here. So this is D. But the next option here is it produces testosterone. Still, the testis or the testes will do this. So this is also D. It's a produce seminal fluid which contains sperms, which contains sperm, so seminal fluid. And seminal fluid is produced by 3 accessory glands. One is called the prostate gland, the seminal vesicle, and also you should have it right here, which is a bulbourethral gland, otherwise called a Cowper's gland. And so this is the seminal. Let me just put that right here for you. Seminal vesicle. Okay, so that also produces fluid as well. And again, you'll have one called right here, small one that is called the bulbourethral gland or the Cowper's gland. All right, and so the answer here will be A, which is a prostate gland for this. This is A. And then it said organ enlarged when filled with blood. And this is the penis or anywhere on the penis. So this is the gland or the head. But the entire penis here will be filled with blood and becomes erect. Okay. All right. So here is the penis. So this is C. All right. Okay, let's just confirm if C. Yeah. I never checked. Yeah. Right. C. Glands or head or the penis. Now part B, it said give the letter to the structure which contains the testes. And so the testes, and it's asking for give the letter, not the name. So the testes are located in the scrotal sac or the scrotum. So that is E right there. This is letter E. And then it said, now briefly explain why the testes are located outside of the body. And simply because now sperm cells, the sperm cells are produced, okay, at temperatures slightly lower than the body temperature, okay, lower than the body temperature. All right, so great. All right, so again, and I could put right here, produce effectively. All right, produce effectively. I also want to put the word effectively right here, because not say it cannot produce, but it produces more effectively if the temperature is lower than the body temperature. Because if the temperature is too high, or even higher than the body temperature, or at the body temperature, then the sperm cells, the immature sperm cells, can be destroyed or become denatured, right? All right, so part D is that on the diagram, place an X on the structure where a surgeon would cut when performing a vasectomy. And a vasectomy is a cut in the sperm duct or the vas deferens. So the sperm duct, let me just put sperm duct right here, or vas deferens. So this is a sperm duct, okay, slash the vas deferens is the same thing. Okay, so vas deferens, okay, the sperm duct or the vas deferens. All right. All right, so here I'm gonna put it on this side. It don't matter. I'm gonna put it on both sides. So normally put it right here, but you must cut both of them though, right? But labeling only one is fine, but the surgeon must cut both. You cannot cut this part right here with the urethra, because you would have a problem urinating as well, right? That would be kind of dangerous, because remember, both urine and sperm come to the urethra, so you cannot cut that part, right? All right. Now, let's jump on to the next part of the question right here. So, okay, so this question, it says state the effect of cutting this structure. And so if we cut this structure, then sperm cells will not be able to be seen in semen. So you cannot, motherfucker cannot release sperm cell. So yes, you may release the seminal fluid, but no sperm cell will leave the body, okay? So in this way, it will prevent sperm cells from leaving the body, okay? From leaving the body. All right, great. Let's jump to the next question right here now. And in this question, it said, water is an important resource and it is filtered and treated with chlorine so that it is safe to use. Okay. And I said, explain why water is filtered. And the filter water is simple to remove the solid particles or to remove any suspended particles. Okay, so to remove solid or suspended particles. Okay, so that's a filtration processes for that. Now, why do you treat it with chlorine? And chlorine is to kill, all right, to kill microorganisms, the microorganisms such as bacteria, okay, such as bacteria. All right. All right, so that's the two method there. Filtration is to remove the solid particles or the suspended particles, and you want to use the chlorine to kill any microscopic organisms such as bacteria. Okay. All right, so now for part B, it said the quality of drinking water can vary. The table gives information on the percentage of ions found in drinking water from 4 locations. And so the locations we have here, we have location A, B, C, and D. We have calcium ion, we have sodium ion, we have the sulfate ion, we have the nitrate ion, and this is the pH level right here. Now for part 1, it asks us now to give the letter of the location where water is acidic. And when we talk about acidic, we're talking about anything, any pH below 7. So there's only one right here, which is 6.7. So this is location D. Okay, so location D will be acidic. All right, this is the only one that is below 7. And then now it asks us now, it said drops of universal indicator are added to water from location C, suggest the likely color change. And let's see what's happening at location C. Location C is 8.2, which means it's a base. And this is a relatively weak base. It's not so strong base. So it's slightly alkaline. Okay. All right. A matter of fact, it is more alkaline than even 7.1 and 7.6, but it's still not strong in comparison to the numbers on the scale. And so suggest the color that we more likely to see right here. So if it's 8, you'll see something close to blue. So it's blue. It's kind of bluish green, really, because it's going on to the base, because neutral tend to be blue. So it's bluish. So let's say bluish green. Okay. So moving from blue into green. So it's bluish green. And then now part 3 here, it states now write the name of 2 compounds which produce the ions present in the water at location B. And so let's look at the ions that are present in location B. So location B here have a high amount of calcium ion and have a relatively good amount of sodium. Well, that's low, really, so 0.6. All right, no sulfate ion, very little nitrate, but you need 2. So we'll focus on the 2 highest one, which is calcium and sodium. Okay, so what could produce sodium? What could produce calcium? All right, so let's think about those. And so what can produce the calcium ion could be limestone, which is calcium carbonate. Okay, so calcium carbonate. All right, and what could produce sodium could be sodium chloride with this salt. Okay, so sodium chloride could be a salt right here. Okay, all right, so those are 2 things right there. All right, so great. And now let's jump to the next part of the question right here. Now it said give the location where the water is more likely to be polluted by fertilizer. Give a reason for your choice. And so let's go back up here and talk about fertilizers. And now in fertilizers tend to be rich in nitrates and also sulfates, right? And so you look at where you see sulfate may be the highest and nitrate may be the highest. And if you look at option A, you have 3.5 and 3 in terms of sulfate and nitrate respectively. And of course, they're the highest throughout the entire chart, a matter of fact. So the greatest amount of fertilizer could be in location A because of the nitrates, particularly the nitrates, right? Because remember that fertilizer is NPK, phosphorus, okay? So nitrogen is for N, P is for phosphorus and K is for potassium. So this will be our location A, and simply because it has a high content of, or high concentration of nitrates, okay? So it has a high concentration of nitrates, okay? Or of nitrate ions, if you want to put it that way, okay? Of nitrate ions. All right, so great. All right, so that will be our answer right there, all right? Okay. All right, so let me see if I could. Hopefully you're seeing this properly. Just want to take it out of the way so you could see it much better. All right, excellent, so it's better right there. All right, so great. Now let's jump to the next question now. All right. So he said, describe the test and its positive result, which shows that a sample of water is pure. And what is a unique substance? So therefore, it could be tested in different ways, right? But again, some method or test may be more difficult than others. And someone ignore the test and positive result right here and put each of them beside each other. So I'm going to show you the test and positive result beside each other because there are a number of them, right? And so one, you could do a boiling test. So boiling. And also you could do freezing. Boiling or freezing. Let's say boiling or freezing, right? All right, let me separate them. So if you boil it, then the positive test here, if it's pure, then it will boil at 100 degrees Celsius, right? So it will boil at 100 degrees Celsius. So let's say boils at 100 degrees Celsius. All right, I just want to do this real fast at 100 degrees Celsius. All right, I will put my degree sign right there. And you can freeze it as well. And if it freezes, so freezing method could be used. And if it freezes at 0 degrees Celsius, so here you're going to freeze at 0 degrees Celsius. All right, so those are two basic tests. But again, some tests may be proved difficult, especially if you do not have the proper equipment to do them. Okay, so that will be our first two tests. Or you could do both boiling and freezing as one experiment. Another way you could do it, is a litmus paper test, right? So a litmus paper test right here. So if you're using litmus paper, then what you will get is that you should have no change in litmus paper. Why? Because pure water is neutral. So if it's alkaline or acidic, that means it's containing something, and therefore the litmus paper will change either to blue or red. But with litmus paper, you should see no change, okay? No change in it at all because pure water is neutral. All right, another test you can use is the universal indicator. So you could use the universal indicator. The universal indicator. All right, and as I mentioned earlier, that water here will be green, more likely green. And moving from green going on to blue, it will be more alkaline. So therefore, you should see a bright green color or a dark green color. So you should see a dark green color, particularly if it is neutral. All right. And what you can also do is what they call an evaporation test. So you can do so you see there are a lot of things you could do right here. So you could do an evaporation test. Evaporation test. And if you do an evaporation test, what you're looking for after water evaporates, you should see no residue. Okay. So no residue or no remains. Okay. So no remains or residue. So for example, let's say water contains salt, right? Is that if you evaporate water, you will see those salt molecules remaining in the container, right? Or you see the particles of deposit remaining in container. So once it's pure, the container should left clean, okay? There's no form of residue. There's no form of salt remaining, nothing remaining in the container, okay? So that's 5 tests you could do right there, all right? All right, great. Now jumping on to the next question here. This question is the finish. So we're going on to question number 6. Okay, we're almost there. It said this question is about bonding, and it said element X is found in group 4 and is a solid at room temperature. Element Y is found in group 1 and is a gas at room temperature. And so right here now it said draw a dot and cross diagram using only the outer electrons to show the bonding formed between X and Y. And so here again now a group 4 and a group 1. All right, so group 4 elements first and foremost will form covalent bond. So that's the first thing you need to remember. And so this element I'm suspecting here will be our hydrogen, because it say that it is a gas at room temperature. So this is hydrogen. All right. And so let's draw our first thing you need to remember here. If element X is in group 4, it has 4 valence electrons. And if element Y is in group 1, that means it only has 1 valence electron, right? And so what you can know how much of each you need is simple to think about the amount of electrons needed. So let's say this is element X. I want to show you this real quick. Element X, element Y, okay? Element X has 4 valence electrons, okay? Element Y has only 1 electron. So here it needs 4 more. This need only 1 more. And so because it need 4 more, I'm going to just do a cross right here. So I'm going to put the number right here, and I'll cross this line as well, here as well. So therefore mean I need only 1 representation, or 1 atom of X and 4 atoms of Y. Okay, so when I draw my X in the middle, I'm going to draw X in the middle since it's going to be 1 of X. And I put X here. Okay, that's in the middle. And then I'm going to draw Y. I think I need to change the color, so at least, you know, you can see the difference between what I'm going to draw right here. And so we need 4 of Y. So I'm going to put 4Y attaching to the 1X. Okay, so 4Y is there. And then I'll put 1 more right here. Okay, so this is element Y. Put 1 more right here. Just kind of evenly distribute them as possible, so you know they fit nicely. And then another Y right here. And then now we're gonna put our electrons in. And remember now, element Y will only give 1 electron to element X. Element X will also give 1, because element Y can't take on any more than 1. So let's put a dot right here. That's the 1 electron given up from Y. Let's put 1 each here. I'm going to use a different color for X. Okay, so I put 1 each coming from the Y, which is the blue. And then now I'll put the electron coming from X as well. So the electron coming from X. So let's do that here. Let's put this in red. And so 1 electron will be given up right here from element X. 1 here from element X. 1 here from element X. Okay, so what they're forming here is all single bonds. Okay, and so that will be the bonding there. All right, and if you want, I mean, there's no need to do this, but X here will bond to 4Y, so it will be X with 4Y. So the formula, if you want to think about the formula, is X and 4Y. All right, if you want to think about the structural formula, then you can put the X in the middle. I'm just giving you some extra stuff right here, and attach single bonded all around X is a Y. Okay, just to make a note of that. So a Y is single bonded all around. Okay, so that is a structural formula there for this compound. All right, this is some extra information, right? All right, so great. Now let's jump to the next part of the question. The next part of the question here now reads, it's a name the type of bond formed between X and Y. Again, this is covalent bond, because group 4 elements, they will form covalent bonds. Okay, it's covalent bond. All right, and so it said now write a possible formula for the compound formed between X and Y. And so it is right here, X Y4. So going to be X. The formula there is X, okay, Y4. Okay, so that is our formula. All right, so let's now jump to the next part of the question right here. So the table gives information about 4 elements, P, Q, R, and S. It also gave us the atomic numbers. So we have 7, 8, 10, 11, respectively, for each of those elements. It said identify the element which has the least chemical reactivity, or reactive, or least chemically reactive. And so the one that is the least chemical reactive is the one that has a full valence shell. And so how we're going to do it is find out the electron configuration here. And so let's just think about this. Let's think about 5 is going to be 2 and 5 here for the 7. For the 8 it will be 2 and 6. Okay, so I'm going to show you something real quick. And then for 10, it will be 2 and 8, which means a stable valence shell, which is the last shell is totally filled. Then 2 and 8 and 1, that's electron configuration for all of them. Now, R is the least chemically reactive. Matter of fact, it's not even reactive, by the way, because it's a noble gas, it's stable. So this will be the least reactive. It is not even reactive, right? And then the reaction of the others will be based up on if they are electronegative or electropositive, which means it can determine by number of shells, because shells will also tell you, like for metals, the greater amount of shells, the more reactive for metals. For non-metals, the least amount of shell is the least reactive. And also, the more valence electron it has, for example, in group 7, all right, which like, for example, fluorine, which is the most reactive non-metal, it has 7, and the shell it only has 2 shells, as a matter of fact. That means the least amount of shells non-metals have, the more reactive they are, all right? And also the least amount of electrons required. So group 7 tend to be more reactive than group 6, okay? And that is going for the same period. So here now we're going to put element R as the least chemically reactive. All right, so let's go to part 2 here. So draw a dot and cross diagram using the outer electrons to show the bonding between element S and chlorine. So let's look what element S is first and foremost, and we not only need the valence outer electron. So this here, element S has 1 valence electron. We only need that 1 valence electron. So again, this is a metal, and chlorine is a non-metal. So this will be a ionic bond. So here we're going to put element S. And element S contain only 1 electron. Let's put that X right here. And let's go to element chlorine, as a matter of fact. So we're going to draw chlorine now. And let's draw chlorine a different color. And so chlorine here, all right, this is already gone to blue. Okay, no problem. So let's do it now with, draw chlorine with red. Okay, so chlorine now, I'm going to put chlorine right here. And chlorine is from group 7. So you can look at the periodic table that is given. And so if chlorine is from group 7, it therefore means that it has 7 valence electrons around it. So I'll put them in circles or dots. Okay. So that's 2. I like to go from the top and go clockwise because it creates the space at the opposite side, which is the left side. So easier for bonding, make it easier to do bonding. I like going from top to in a clockwise way. It's very easy to do it like that. And so that's 6, 1 more makes 7. Okay, and so what we're going to do is the bond now. We're going to transfer this 1 electron over because in ionic bonding, electrons are being what? Transferred. And so the 1 electron is being transferred, and if that electron is being transferred, that means no more can go over to chlorine. But what I need to also note is if chlorine is filled as a filled shell, so I'll put this right here, and this is 8, and since it's 8, that means the valence electron, the valence shell of chlorine is also filled. That means the bonding is completed. And so the formula for this, let's write the formula for this here. It only requires 1 S, whatever S is. In the periodic table, S will be for sulfur, but again, this is not the symbol, as they said. All right, so here going to be SCl, okay? And a possible, if you think about the periodic table, a possible element that could be in group 1 that could bond with chlorine, that could be sodium chloride. Okay, just in case they ask you that in the next exam, you know what to do. All right, so just look in a group 1, and you will get any possible element from group 1. All right, so again, the type of bond that is formed right here is ionic bond, and it's between a metal and a non-metal. So this bond is ionic bond. All right, let's jump to the next question here. It said, okay, this is the next part of the question, last part of this question. It said, in terms of electron transfer, what happens when S bond with chlorine? And simple because here that electron, 1 electron, I'm going to be very specific with this. 1 electron, okay, is transferred or being transferred, is being transferred from element S to chlorine. Okay, so transfer to chlorine. This is a 2-mark question here. All right, making both elements having a stable electron configuration, right? Which simply means that the last shell of each element will be completely filled. Okay. All right. So that is for that. Let's go to the next question here. And this question is a diagram shows cells in a sample of human blood. And these small guys right over here, these are our platelets. So let's call these platelets. Okay. That's platelets. And this irregular shaped nucleus, here we know this is phagocyte, which is a white blood cell. Okay, so this is phagocyte. And this over here, which is a nicely shaped nucleus, and this is lymphocytes. This is a lymphocyte. And let's go down a little bit more. We have these here with no nucleus, which are biconcave shape. So these here are red blood cells, otherwise called erythrocytes. These are red blood cells. The red blood cells, otherwise called erythrocytes. Okay, let me just quickly shift this over a little bit for you. All right, so red blood cells, otherwise called erythrocytes. Let's jump to the next question, or jump to the questions really. And we're almost there. Is to state the name of the fluid part of blood, and the fluid part of blood here is called plasma. Okay, so that's plasma. And then it says state the function of S, and S there is red blood cell. And so S here is red blood cell. So red blood cells, they transport oxygen. The main function is to transport oxygen. Okay. It will also take carbon dioxide from the cells as well, going back out of the body. But here, let's talk about transport of oxygen. That's the main function. So describe one way in which cell S is adapted for its function. And cell S here is the red blood cells. So how red blood cells are adapted for their function is a number of reasons right here. Some have given more than one reasons. And so one here, no nucleus. And having no nucleus, how is that advantageous? Is simple because no nucleus, you have more space to carry more oxygen, right? Yep. Another one here is that it is biconcave, and biconcave increase surface area. So it's biconcave, okay, biconcave. And being biconcave, it gives an increased surface area. So let's just say right here, increased the surface area. Okay, just to give you the information here, surface area. And no nucleus simply mean it has more space in it. So I'll put more space. Okay, so here we have more space, and more space to transport oxygen. Another possible right here, well, large surface area is there already. So I was going to say large surface area. So those are the two things. No nucleus, more space to contain oxygen. Biconcave create a large surface area. And also the biconcave allow it to pass through the blood vessels easy as well, right? Okay. All right, so those are the two main adaptations there. All right, let's go to this part now. So explain how structure P, Q, and R protect the human body against microorganisms. So let's talk about what P is first. So P is the platelets. And platelets is really a secondary defense, I would say, because it do not fight the microorganism directly, but it does, they do something that is very important. And so platelets is responsible to clot the blood. And so what platelets will do, okay, platelets will clot the blood. So let's say right here, so clotting of the blood, clotting the blood, okay, so clotting the blood, causing the site of the wound to be closed, okay? All right, so clotting the blood, let me just write this short, clotting the blood and closing the site of the wound. So wherever you get the wound, the site there will be closed. So when the blood clot is, close it. So once this site is closed, then it's more difficult for microorganism to enter the body, right? So that's the first defense when you get a cut, is to clot the blood, so you do not lose blood cells. All right, so you stop the bleeding, and then because the bleeding is stopped as well, secondary, it will also prevent the microorganism from entering. So it's a good way to defend the body from the entrance of microorganism. Now Q, now let's see what Q is again. Let's look what Q and P is, Q and R one time, so we don't have to go back to it. So Q is the phagocyte, and R is the lymphocytes. Okay, so let's go where phagocyte is first. So Q is the phagocyte. And how it else again microorganism is simple. They will engulf. So they engulfed and digest. Okay, engulf and digest microorganisms. Okay. All right. So that's what is happening. They kill, eat, destroy the microorganism. Let's say such as bacteria. Just give you some information here. Bacteria and viruses. All right. And not only viruses, but any microorganism that enter the body, yes, it will attack them and eat them up, open up, take them in, digest them, break them down. All right, so R now, which is a lymphocyte. So lymphocytes now, they produce antibodies. So produce antibodies. Okay. They produce antibodies. And antibodies that will kill microorganism. Okay, that will kill microorganisms. All right, so great. So those are the how these help to protect the body against microorganism. So yep. So clotting, prevent them from entering. Phagocyte engulf and digest them. Lymphocyte will produce antibodies that will kill the microorganisms. Now for part B, now we say a student performs a series of exercises to determine his fitness. The results are recorded in the table. And so right here now, say calculate the average heartbeat for the 3 exercises. And so the 3 heartbeat have 75, 55, and 90. So we're just going to add them and divide it by 3. So it's going to be 75 plus 55 plus 90. Okay, and then we're going to give that as a total of 222. And then we're going to divide 222 now. Let's put it at the bottom right here. So 222 divided by 3, that will give us here 74 heartbeat per minute. Okay, 74, not 77, 74. And this is 74 heartbeats, okay, per minute. Okay, because remember that is per minute. All right, so great. Let's go to the next part of the question here. It says, explain and give a reason for the effect of exercise on heartbeat. So why heartbeat increase? In other words, because heartbeat is increasing when you exercise, right? So the effect of exercise on heartbeat is increase the heartbeat, or the heartbeat increases, and there's a reason for that. So let me just say heartbeat increases. And there's a reason for it, is simply because is to pump more oxygen and glucose to the cells. So this takes place to pump more oxygen and glucose to the cells, and this is for respiration, right? Or for producing energy, okay? For respiration, which is producing energy. So once you exercise, you want to get more energy, okay? For respiration. Or you can just see simple energy production, right? For more energy production, or to give the body more energy during exercise. Now, here now, it's apart from exercise, give 2 other factors which may decrease a person's risk of coronary disease. And so what can you do to reduce the possibility of you having coronary disease? Is 1, you can eat less fatty food, okay? All right, so reduce, right, so decrease a person's risk. So 1, you can eat less, eat less fatty foods, okay? So that's one way right there. You can also reduce salt intake. So I'm put it right here. Reduce, because salt, a lot of salt gives hypertension, which is high blood pressure. Okay. Reduce salt intake. Okay. You can also eat more fiber as well, because fiber assists you with the digestion process. You know, so you release more waste and don't keep them in the body stored. So eat more fiber, okay, or fiber food. And of course, again, what you can do is to drink adequate water, because water is important to take away the excess salt out of the body, and also to just improve digestion. So drink adequate water, or more water. Okay, so adequate, let's say adequate water. Okay, so drink adequate water is another good one right there. All right, so great. All right, let's just move this down. I think I need to get this out of the way. All right, so you can see this better. All right, I know you know what's there, but yeah, just put it right here. Okay, great. So those are some of the things that you can do to reduce the possibility of coronary diseases beside exercising. All right, so your diet is very important, right? The diet is very important. What to eat, what to take in is very important. All right, so number 8, which is the final question here. And this one now reads that the diagram shows the dimension of a glass tank with water. So I'm going to assume now that the water is this line right here, okay? And now it said that the first question, let's go down to the first question here. It's a calculate the volume of water in the tank. And so the water in the tank will be the dimension of 6 by 6 by 7, base times width times height. And so here we're going to multiply 7, multiply by 6, multiply by 6, and that will equate to here 252, and this will be centimeters cube. Okay, so the centimeters cube. Let's draw in that centimeters cube right there. Okay. All right, so that's centimeters cube. All right, great. Now that's cube kind of big, but yeah. All right. Now let's jump on to the next question. You see a stone on a piece of string is lowered, right, into the water in the tank until it's completely covered. The water rises to 8 centimeters. Okay, calculate the volume of water and the stone. So now the height is changed from 7 to 8. And so we're going to calculate that now. And so we're going to calculate what we're going to do here. We're going to multiply, instead of using 8, we're going to say, okay, 8. Instead of using 7, we're going to say 8, multiply by 6. Multiply by 6 because the new height is now is 8 instead of 7. And that now will give us 288 centimeters cube. Let's draw that in. All right. All right, so great. All right, so that's our 2 volumes right there. The next part here is to find the volume of the stone. So the volume of the stone will be the water by itself minus, it should be the water with the stone minus the water. So therefore, to find this, what we have to do is to say 288, take away 252, and that will give us 36 centimeters cube for the volume of the stone itself. Okay. All right, now the next part of the question here reads that the stone has a mass of 64 grams. What is its density in kilograms? And so when I say kilograms here, what is actually meant is going to be kilograms per meters cube, because what I want you to remember, density is either gram per centimeters cube or kilograms per meters cube. Okay, so I want to make this into meters cube. Okay, so again, remember that density can only be of 2 units. It could be kilograms per meters cube or grams per centimeters cube. Do not mix and match your units. Okay, please do not do that. What I could also tell you again is that 1 centimeters cube is the same thing as 1 ml. So it could be grams per ml as well. Okay. All right, so let's look at this now real quick. It said, okay, so we're going to find the mass right here. Okay, so the mass of that was the density. Let's calculate density real quick. So the density now, to find the density, all right, what we're going to do here, let's kind of do some conversion real fast first, because we want to find kg and we want to find meters cube. So first and foremost, let's convert the grams into kilograms first. Okay, so grams into kilograms are divided by 1,000. So therefore, let's say 64 grams. Okay, 64 grams, right, is equal to, divide by 1,000, give us 0.064. Yep, 64 kg. Okay. And now let's now do another conversion right here. Let's convert our meters cube, because this is of the stone, right? The volume of the stone is 36. It is 36 centimeters cube. So we need to convert this into meters cube. So to convert centimeters cube into meters cube, we're going to divide by 1,000,000. Okay. And why 1,000,000? Because it's a cubic. So centimeters to meter, you divide by 100, right? So it's 3 of them. So 100 times 100 times 100. That gives us 6 zeros, so that's mean 1,000,000. So we divide the 36 now centimeters cube, okay, into meters cube. So we divide by million. So there you're going to get 0.000. That's 4 zeros because it's going to be to the negative 5, 0.036. Okay, and this is again in meters cube. So let's put the cubic on both of them. Okay, so the cubic will be here. This will be cubic. All right, so now we have that. Now what we can do now is to go ahead now and do our density. Density is mass over volume. So mass over volume is density. Okay, so we can put mass over the volume. So what we could do here, now say the mass, let's put it here, let's go back here. All right, so the mass here will be, let's put it a little bit further down. Okay, right here is sufficient. So we're going to divide 0.0, okay, 0.064, okay, which is a mass, divided by 0.40 in front of the 3. All right, because 0.5, and then it's going to be 36. And the answer here now will be, let's put the answer right here. So this is all equal to, okay, let's put the answer at the bottom here so you don't jump over the page. So the answer here now will be, let's put this also in red. I can do that. All right, so the answer here, when you divide both numbers, you get 1,777.78, and this is going to be, again, kilograms per meters cube. Okay, and so let's put our cubic on top of this. Okay. All right, so that will be your answer right there. Okay. There's also a shorter way to do this by just simply find the density in grams per meters cube first, and then just multiply by 1,000. So you could just divide the 36, which is in centimeters, the 64 by 36, that is in grams per centimeters cube. Then you multiply by 1,000. So let me just quickly show you over here. So just in case you're in the exam, I want to do this. Let me make sure I put this in a different color again. So a different way to do this, you can have your grams. So your grams per centimeters cube. Okay. All right, let's call it C. So centimeters cube. Okay. If you want to convert this into kilograms per meters cube, this would be kilograms now per meters cube. So once you find the density in grams per centimeters cube and you want to do that, all you need to do is just to multiply by 1,000. Okay. All right. So that's another short way to do it. All right. So just work it out first in grams per centimeters cube, then divide, then multiply by 1,000. That will be your answer, right? Okay, that's another way. All right. Now let's go to this part of the question here, and we're almost to the end. It said the density of water, right? The density of water is 1 gram per centimeter cube, per centimeters cube. It says state what happens to the stone if the string is let go. Give a reason for your answer. Now, first and foremost, you have to compare the two densities, right? So we could convert this 1,777.78 kilograms meters cube per meters cube into grams per centimeters cube by dividing by 1,000. So if we divide this value by 1,000, what you'll get is 1.7, okay? Which means the stone is more dense. So let me just quickly show you right here. So if I divide the answer up there by 1,000, I will get 1.78 as the density for the stone. So this will be the density of the stone. That of water is 1. So water is 1. So water is 1 gram per centimeters cube. Okay, so just to make a note of that, we compare the densities. I'm just doing this for show you for the reason what I'm going to explain to you. And so the stone is more dense, so therefore the stone will what? Sink. Okay, so the stone will sink. Let me put this back now into blue. So here now the stone, okay, will sink. The stone will sink because it is more dense. Okay, because it's more dense, compared to water, all right, or it is denser than water. Okay, and the last part here, this thing is the last part of the question, right? It said, why does ice float? And ice float because simply, no, this is only unique for water, okay? Because solid water is less dense, okay? Is less dense than liquid water, okay? All right, so the solid form of water is less dense than liquid water. That's why it's float. And the reason for that, because water expand on freezing, and when it expands, the volume increases, and therefore means that it decreases the density, because a higher volume over the same mass give you a less density. Okay, the density is less. Okay, so again, water is the only solid that expands when freezed, all right, and therefore it decreases the density. Okay, so water is less dense as a solid. And this is where we end for today. Again, I see you again for another review. Keep safe, keep blessed, and do well.